So in the previous section of this multi-part series, we looked at the hardware components that make up the N0AGI's International Space Station IGATE. In this video, we'll talk a little bit about the software layer that makes up the solution. We will go through a list of choices that are available to us in the market today and talk a little bit about what each of these software products offer. I'll talk a little bit about why I chose a particular software for this application. So let's get started. So typically, if you look at IGATE and DIGIPEATER software available to us in the market today, there's quite a few. And each of these brings to bear its own features, benefits, highlights, lowlights, third-party software dependencies, and so forth, complexity, user experience, and you name it. So what I've done is I went through a list of choices that I thought might be useful to take a look at. To name a few, I looked at APRX, Exastor, YAC, UISS, UIView, and DIGPRS. What I'll do here is go through some of the features that I had noticed that played a role in my decision as to which way I went. So if you look at APRX software, it is completely config-driven product. So there's no UI from a graphical UI standpoint. The UI is completely textual based. It's configured using config files. It's simple to set up, easy to acquire, easy to install. There's few features that are available through the command line interface. There's some moderate learning curve involved because of some of the jargon, some of the terminology the product uses to define its behavior, but nothing too complicated for someone to pick up and run with. It's available in the Debian platform. It's completely free. It's open source. There's a growing community of developers and users for APRX, and the group is extremely active. Exastor, on the other hand, is heavily UI driven. It is also like APRX, highly configurable. It's easy to set up. There's also limited features available through the command line. There's some learning curve involved because there is some UI customization that's part of the experience. So there's some enhanced learning curve that's involved as part of this product. There's also some mapping features for visualization. It's Linux based. There is a large following for Exastor and an active group out there. YAC, on the other hand, is also config file driven. It is also highly configurable, simple to set up. I think one of the big differences between APRX and YAC is written in Java, which means that you can run this application both on Windows as well as in Linux. One drawback that I noticed is it relies on a third-party software. It's both Linux and Windows available. UISS and UIView, they probably have the largest following of users today from an International Space Station application standpoint. I downloaded the product, tried it at least a few times. It's just way too complicated. Its UI I felt like it was an overkill. And I think the complication comes in from how the UI is structured in the application. The application is also highly configurable. There's some confusing setup involved because it needs or it depends on a third-party software. There's very limited command line features that you can pass. But once you get the hang of the UI portion of it, I think people have found UISS to be very comprehensive. It is a Windows-based product, and I believe it is free, and there is some large following of the products. DIGPRS, I was told that the product is very comprehensive, very user-friendly, configurable through config files. But unfortunately, I couldn't do much of a testing with it because the product is no longer active. So as you can tell, there's a lot of choices out there. For me personally, I like to work with config files. I try to minimize the UI interaction because I like to keep the product configurable through config files, number one, but number two, also be able to control the product through command line features, to be able to shut it down, bring it automatically up, and things of that nature. Mostly from an autopilot standpoint, so that you're not babysitting the product that requires user interaction from a UI standpoint, but something that can work and be functional based on the configuration files. So with that, I chose APRX as my choice of platform. And here's some of the reasons why. It's completely configurable using the config files. You could also define APRX's functionality and how it behaves at various levels. You can start it out at a very basic level, namely an RX only IGATE, where you're only listening into packets, you're not really transmitting RF packets out. You are receiving the packets and you're IGATing those packets to the APRS-IS servers via internet. There's also another feature where you can enable the transmit IGATE, where you are doing an RF transmission, and there's also APRS-IS to RF digipeating. There's RF only digipeater without any APRS-IS involved, and many more features. As you can tell, there's a lot of choices available that you can configure using the config file and be up and running in no time. So if you look at the other pieces of this software, there is some learning curve involved. Not so much how to use the application, but more so what some of the terminology means from an application standpoint. And you will hear a little bit about that in this video. The latest version of the product is 2.8.2, and here are some of the resources available. So what are some of the functional objectives for the N0AGI's ISS IGATE? Because that's going to help define which functions to enable versus not based on the objectives I want to accomplish. One of the primary goals is to receive RF packets on the 145.825 frequency, which is the ISS frequency here in the United States, and receive only those packets that were heard by the RS-0ISS call sign. RSS-0ISS is one of the call signs available on the International Space Station under the alias of ARISS. Once I receive those packets, I want to be able to take those packets and then IGATE only those packets to the APRS-IS server pool via internet connectivity. And once I IGATE those packets, I will now want to digipede them back to RF. And last but not least, I want to be able to send recurring beacons over RF using the via ARISS parameter in my beacon. The reason why that is important is because I want beacons to be received by the International Space Station's digipeater and digipede them back to the Earth. The ARISS digipeater on the ISS is listening for packets with the via ARISS parameter in them. I also want to be able to beacon packets to the APRS-IS directly for situations where people are able to locate my station as a service. So here's a quick flow of how this works. So if you look at the workflow here, there is my station here that has a radio that's capable of reception and transmission, that's tuned into 145.825, and that's hooked up to an antenna that's listening for packets from the ISS. And then the APRX software is running on Raspberry Pi with a tnc-pi attached to it, and then the APRX software is up and running based on the configuration in the config file. The APRX software checks for whether it's time to beacon. It sends out beacons to the APRS-IS directly, and it also sends out a beacon through RF using the via ARISS. If the time is not quite ready for beaconing, it kind of goes back into a loop to wait for that time to pass. The second part of the functionality is to listen in on packets that are already digipeated by RS-0ISS. And then once those packets are available, it takes those packets and IGATEs those packets to the APRS-IS server pool. and then it digipeats them via RF. So that's it really in summary. So let's talk a little bit about the how-to aspects of APRX. So APRX works on this notion of there is a packet source and there is a packet destination. A packet source can be things like your radio listening on a certain frequency. In other words, APRX calls it interface. An interface is a radio that's listening in on a certain frequency, sort of a notion. The interface can also be a destination in this model, meaning you not only are able to hear the packets, you're also able to send packets through this. So it's both a source as well as a destination. The second bucket that can act as a source and as a destination is the APRS-IS server, wherein you are able to send data, in which case it's a destination. You're also able to receive packets from the APRS-IS server, in which case it acts like a source. I'm going to be using the APRS-IS as a destination and not as a source.